Alrighty. Hello everyone, and I hope you're feeling well and relaxed, but if not, don't worry, because today we're going to be taking the edge off. And specifically, we're going to talk about edge computing and see for ourselves what the hype is all about, whether it's something worth investing your time into or not, and in the end, we'll deploy our own little Cloudflare worker to better crystallize our understanding on practice. But first, let me introduce myself real quick. I'm Alexander Baygeldin. I'm a backend engineer at Evil Martians, but I also have to do a lot of front-end and, in general, setting up infrastructure for web applications on a daily basis. And this experience is what actually pushed me to give a talk on this topic in the first place. However, no matter what kind of work you do, front-end, back-end, DevOps, doesn't really matter. I'm sure that edge computing will have something to offer you. Let's start by clearing up the terminology first. So, what is edge computing exactly? Wikipedia tells us that edge computing is a distributed computing paradigm that brings computation and data storage closer to the sources of data. And in a nutshell, it means that we keep our data and computation closer to our users instead of forcing them to fetch it from a central location. But this is a very broad definition. Like, how close is close enough to be considered edge? So let's narrow it down a bit. And here on the slide, you can see the locations of all of the data centers, all of the Cloudflare's data centers around the world. If this map looks familiar to you, then you've probably taken advantage of Cloudflare's global network before. Because this is one of the most popular, and it was and still is one of the most popular content delivery networks in the world, which main purpose is optimizing delivery of static assets. However, over time, it grew in functionality and became programmable. So now you can deploy your own code to all of those data centers with a single stroke of a button. And this is what people usually mean by edge computing today. A distributed network of data centers scattered all around the world where you can run your own code close to your users. And by the way, this is specific to Cloudflare, but whatever provider you choose is going to have something similar. The next thing I'd like to clarify is the relationship between serverless and edge computing. So they're very similar in the sense that you use them by writing functions that represent pieces of computation. In serverless, they're called serverless functions. In edge computing, they're called edge functions. And in both cases, we pay for execution instead of provision capacity. And you don't have to worry about the servers that need to be managed, scaled up, scale down. All you have to do is just deploy the code and let the cloud provider handle the rest. However, when we're talking about edge computing, we put our focus on where these functions are run, geographically speaking. And this gives us some unique benefits. For example, reduced latency. And this is like the most obvious benefit because it's a direct result of that emphasis on data locality. So we can beat physics, yet at least. And even if we transfer data with the speed of light, it would still take it about 130 milliseconds to travel around the world, which is not that fast if you think about it. So say if a user in Lisbon makes a request to a server hosted in California, it would easily add 100 or 200 or even more milliseconds of latency just by round-tripping across the Atlantic Ocean. So what does it matter? These numbers may not seem like a lot, but in certain applications it does matter. For example, healthcare and autonomous vehicles. And this is because there's almost no margin for error. Even like a few milliseconds can save a person's life. Another example is AI assistants, for example. So they are not currently run at the edge, but I think they're going to be relevant in the future because we want them to be conversational. Otherwise, they're going to be like, they will fall in that death valley trap, as we all aware of. And the next benefit is saving money on bandwidth costs. So this one is especially important for applications that are data intensive, such as IoT, for example, where sensors or devices can generate tons of data, which would be just expensive and inefficient to process in a single location. So what we can do instead is we can distribute this load over a larger amount of servers, aggregate the data there, and then send it to a central location. And this is what edge computing can offer us. So why does it matter? As I said, IoT is the example that comes up the most, and actually the one from which the demand for edge computing originally came from. Apart from that, obvious winners are applications doing a lot of heavy content delivery, like video streaming platforms like Netflix and such. Before we get into the next benefit, let me squeeze in an interlude first. So let's recap what has been on the cutting edge offered us so far. First, reduce latency. Second, saving money on bandwidth costs. And this is pretty cool, but in my opinion, it still doesn't explain the popularity behind edge computing and the reasonably sized hype around it. So something else is going on here, and I have a strong opinion that it's actually front-end developers' fault. I know this is probably every backend developer's motto, but still, hear me out. If you've heard the words remix or React server components before, then you probably know what I'm talking about. But if not, let me explain. So you know how at the dawn of web, every web application worked by serving static HTML, maybe with a few sprinkles of JavaScript code? And we call these applications retroactively multi-page applications, or MPAs. And they work great. Pages loaded fast, especially you could throw a CDN on top. But web applications were becoming more and more interactive, and it became difficult to manage the client-side code complexity without a proper framework, which gave birth to libraries such as React. And then, overnight, every web application became a single-page application, or SPA. And they started serving empty HTML pages with huge JavaScript bundles, several megabytes in size, that were responsible for rendering that application in the browser. As you can imagine, this did not reflect well on the loading speed, because before the user can actually see the content of the page, the JavaScript code had to be downloaded, parsed, and executed, which in turn triggered additional network requests to fetch the data from the backend, resulting in those infamous network waterfalls. So smart people thought, hey, why don't we pre-render the HTML on the server and serve it alongside the JavaScript code? And this was called server-side rendering, or SSR. And it kind of fixed the issue, like partly, but introduced its own set of difficulties, like hydration on the client side, for example. And it still didn't fix the bundle size problem. The bundles were still huge. So smart people thought again, hey, why don't we move the computation to the server and just ship as little as JavaScript code as we possibly can? Now, if this sounds like a multi-page application to you, then you're not alone. In a sense, we kind of came back in full circle and returned back to where we started, doing heavy lifting on the server and adding sprinkles on the client side. However, the difference with jQuery era multi-page applications is that you can still use the same component-based approach that enables you to make very complex web applications. So I'm not going to go into the details of how this approach works, because this talk is not about this, but I can say that pioneering this paradigm shift in the front-end world is React with their server components, for example. Okay, so now that you know all this, you probably have one question. What does it have to do with edge computing? Okay, like if we move the logic to the server side, does it necessarily have to be executed on the edge? Can't we just render server components in a single location? Yeah, and you most definitely can. Because if the latency, extra latency doesn't scare you, there's nothing preventing you from doing that. However, when we asking ourselves these questions, we have to consider the fact that front-end developers were using CDNs for ages to serve the code to the client devices as fast as physically possible. And now that traditional CDNs don't cut it anymore within the new paradigm, kind of going back to the central servers would feel like a downgrade, which it is, by the way. And the only way to embrace the new paradigm without compromises is deploying to the edge. Why? Because it allows you to serve dynamic content at the speed comparable to static content. So, getting back to the original point about the hype behind edge computing, I'd say that it's rooted in the fact that front-end development is inevitably moving to the edge. But, this wouldn't be possible if it wasn't for the last, but not least, benefit of edge computing and its developer experience. So this one doesn't actually have anything to do with edge computing per se. However, it's a consequence of its widespread adoption. But I think this is what makes it so great and relevant today. Because historically, multi-region deployments were difficult and expensive to set up. So in the majority of cases, it simply wasn't worth it. But modern platforms make it extremely easy to do, which opens up a lot of possibilities and unexpected use cases. Like what? For example, you can cache all sorts of stuff at the edge that you were never able to before with traditional CDNs. You can enrich the responses at the edge with the data relevant to the user's location. You can streamline A/B testing without encoding this logic into your main application. And these are only a few examples, but really the only limit is your imagination. Just think of edge functions as proxies sitting behind your user and your origin server that can manipulate responses and requests in whatever way you like without adding any additional latency. Well, maybe just a few, but pretty good. And you know what? There's just something magical about being able to deploy something everywhere all at once with almost zero operational overhead. If you ever use Heroku, for example, this is the kind of magic we're talking about. So in case of Cloudflare Workers, for example, all you need to do is just write a few lines of JavaScript code, hit a single command in your terminal, and boom, your code is deployed to over 300 data centers around the world. It's pretty cool. Okay, so now let's look at a few real-world examples from our own experience working with one of our clients, Playbook. So Playbook is a cloud storage platform specifically designed for designers. And it makes it super easy to organize, collaborate, and share your work. So yeah, quick shout out to Playbook, great product, great team, and I highly encourage to giving them a try, especially if you're a designer. All right, so we first felt the need for edge computing when implementing server-side rendering, or SSR, for a subset of application pages that were dynamic but context-free, meaning that these pages looked almost exactly the same to all users, but the contents could change in the runtime. And these pages suffered from the same problems like bundle size and network waterfalls. So, like every single page application. And SSR was a natural solution here. However, it was impossible to implement it without a huge refactor of the front-end code. And this resulted in users waiting for several seconds while waiting until the page is rendered on the server while staring at the blank page. This is not a great user experience. So what we decided to do instead is we decided to serve the client-side rendered version of the page until the SSR cache was ready, then caching the SSR in the background and revalidating it on every request. So kind of like stale while revalidate pattern. And this wasn't possible with traditional CDNs, but with edge functions, it was not a problem at all. And in fact, later we realized that we also needed to add some kind of authentication to these pages. Again, not possible with CDNs. With edge functions, it was not a problem. The next example is about safer rollouts of bigger features. In our case, there were at least 2 examples when, after a big refactor, we decided to test it safely on a portion of users first, before rolling it out for everyone. And what we did is we set up a new application instance and also configured the edge function that routed the user traffic based on our custom logic. And it worked out flawlessly. And it only took a few lines of JavaScript code. All right, and the last example that I want to mention is probably my favorite, because we got rid of the Nginx reverse proxy in our infrastructure and completely replaced it with Cloudflare Workers. So I don't know about you, but every time I have to make changes to nginx.conf, this is what I see. It literally looks like ancient scriptures to me because I don't have to do this often. I don't remember how to write this nginx configuration. On the other hand, I write JavaScript only like on a daily basis. So making changes to the Cloudflare worker is a lot simpler. As a result, not only we improved maintainability, but also reduced latency and acquired a useful tool for a toolbox that is a lot more flexible. Okay, so far we've talked about how awesome edge computing is. But of course, it's not all rainbows and butterflies. And the issue that you're going to be dealing with if you adopt edge computing is, of course, data consistency. Just like we can beat physics, we can beat cup theorem. So in exchange for high availability and performance, we pay with being unable to access the most recent data on the edge. And depending on which data storage you use, the approach to this issue would be different. And Cloudflare actually has a lot of data storage options available for different use cases. So for example, you can store data between requests in global variables and about up to 128 megabytes in memory. Or you can cache the whole HTTP responses using the cache API. By the way, these are like local to the data center. So there's no replication, and we don't talk about consistency there at all. The KV storage is a lot better. It's eventually consistent key value storage, and it has a central storage where the data is persisted, and it's replicated to all of the data centers around the world. And it uses pool-based replication. So whenever the TTL, time to live, for a given key runs out on the edge, it will pull the new data from the central storage. That's how it works. Then we have D1. D1 is a distributed SQLite database, kind of like LiteFS, if you heard about it, from Fly.io, very similar. And it uses some kind of append-only log, where writes are forwarded, like they are handled by a central instance, and reads are performed locally. Then we have R2. R2 is a S3 compatible blob storage, which is not replicated by itself, but it can be used in combination with Cache API to achieve this. And finally, we have durable objects. So durable objects are like really unique beasts, and I don't really know what to compare them to, but you can think about them as normal objects in sense of like in object-oriented programming kind of sense. So they have methods and they have state, but the difference is that their state is persisted on disk. And because this state is private to each durable object, we have strong consistency. But it also means that there is no replication. So there's only a single object with the given ID worldwide. However, these objects do migrate between data centers transparently to the users where they are needed the most. And this is pretty unique. And before we get into the demo, let's look at a few more features of Cloudflare. Well, first of all, there's no cold starts. Like, you can just forget about them. And this is mostly because your code is not run inside containers, like usually. Instead, it's run inside V8 isolates, which are super cheap to operate, and they allow you to spin up new workers super fast, which is probably the reason for pricing being so generous. So on free tier, we have 100K requests a day, and pro plans start from $5 a month, which is, yeah, pretty cheap. Then we have WebAssembly support, which means that you can use any language that compiles to WebAssembly, so not only JavaScript and TypeScript, like Rust, for example, if you are that kind of guy. And then there are cron triggers for periodic jobs and WebSockets and whatnot, but these are just the highlights. You can get yourself acquainted with the other features on the Cloudflare's website. finally, let's get into the demo. So I'm gonna just walk you through the process of deploying your first Cloudflare worker, and I guarantee you that you can replicate this process at your own time later. So I have this website. It's a homepage, and it's really just a placeholder with this image and a caption that says "Hello World" below. It is deployed to GitHub pages, so it's a static website. But in your case, it could be whatever, hosted wherever. Doesn't really matter. And I also set up the Cloudflare for this site. So the DNS provider for this site is Cloudflare. And just so you know, this is just a fresh account, like free tier, absolutely default setup, nothing fancy. And assume I have no workers installed. So what would it take for me to start using Cloudflare Workers on my website? And the answer to that is literally 2 files. And the first file is the configuration of your worker. On the slide, you can see like the most basic example. All you need to do is specify your Cloudflare account ID, which is public information, by the way, so you can commit it to your repository. It's totally safe. And the routes where this worker is executed. In this case, it's executed on all routes. But you can also mount it to only specific subroutes or even to subdomains. So it's pretty flexible. And then we have the actual code of our worker. As you can see, it's only 5 lines of JavaScript, and it does exactly nothing. Well, it does something. It passes the request through to the origin server, as if there were no worker at all. And it accepts 3 arguments. First is the original request object. Then there is the env object that has bindings in Cloudflare terms, but you can think about it as object with environment variables. And we have the CTX, which is context, execution context, that has some useful APIs that we'll look into later. All you need to do is to install the Wrangler, which is a command line tool for managing your Cloudflare workers. Then execute Wrangler login, which will open the browser tab, and you will authorize it. And then just hit Wrangler deploy, and there you go. Your code is running all over the world. And yeah, that's all it takes, really. And from there, you can do whatever you want. So for example, if I wanted to return the world hello world on a specific route, this code should do it. And sure enough, it works. But let's do something more interesting. So how about showing the user their geolocation? And this is also easy, because Cloudflare provides this special CF object on the request object that contains all sorts of useful metadata. For example, you can access the code of the Cloudflare data center where the request is currently executed in. And it's called colo, or it's short for colocation. Some people also call it point of presence, but doesn't really matter. And then we have also country, time zone, city, and whatnot. So if we add some styling, this is how it's going to look like. And you can actually just open it on your mobile device or whatever by following this link in the address bar. So baygeldin.name/geo. But this is still kind of not super sophisticated. So let's turn up the heat a bit. You remember that on the homepage there is a caption that says "Hello World" right below the image. Let's translate it to the language of the country from where the user is visiting from. And we can do this with HTML rewriter. HTML rewriter is one of the many, many useful APIs that are available inside Cloudflare Workers. And as you can see, all we need to do is to assign the callback that searches for specific HTML selectors. In this case, it's span element with caption ID. And then inside this callback, we manipulate the HTML in whatever way we want. And this is very important to note that it doesn't work by downloading the HTML content from the origin server, then transforming it in the memory, and then returning it to the user. All of these steps are happening simultaneously because all of the APIs inside Cloudflare Workers work on streams, because otherwise it would introduce significant latency. So while we are transforming this HTML, we would be already streaming the HTML to the user. But now let's actually translate the word instead of hard coding it. And lucky for us, there is a public API that can do this. It has translations of the word hello to any language, any known language in the world. And yep, that's all it takes. We just fetch this API inside our callback that we saw on the previous slide. You know, this is like not super efficient. We want to cache this stuff so that we don't make the requests on every request to our homepage. And for that, we can use KV. So there are a lot of ways you can cache stuff in Cloudflare Workers, but the one that you're gonna use the most is KV because it's easy to use. So as you can see, we just fetch the cache from the KV storage, and only then, if it's absent, we make the request to the API and then cache it in the KV. I want you to all pay attention to this line with wait until at the end. So this is one of the APIs available inside execution context, and it allows you to execute asynchronous operations in the background. So even after we serve the response, so that we don't block it unnecessarily. And sure enough, it works. And you can see it for yourself if you load this website from different countries. For example, if you like turn on the VPN, or I don't know, if you travel to another country. I know that you're probably thinking that, well, this is cute, but I doubt that production usage would be just as simple. And you'd be absolutely right. In fact, I can list at least 4 things that you want to have in your starter pack when starting using Cloudflare Workers. First, you need the router, like something like Express.js, but not as outdated, and that allows you to assign handlers on different routes and use middlewares. And I recommend Hono.js for that. So it's actively developed and specifically designed for edge computing. Then we also need a linter. I just recommend to use the standard JS to save yourself a headache. And of course, we need to set up tests. So this one was a pain point for me personally, because there's almost zero documentation on how to write the test for Cloudflare Workers properly, let alone how to configure it. But lucky for you, I decided to save some trouble and created the repository. So it contains all of the examples from this talk and all of the configuration that you need to bootstrap your own Cloudflare worker. So you can check out the repo by scanning this pretty QR code or just following the link in the slide. If you already use Cloudflare and haven't tried Cloudflare Workers yet, then I highly encourage you to clone the repo, modify it, and deploy it to your own account. And then you can see for yourself how easy it is to start using edge computing. So don't just take my word for it. And if you do try it, then I promise you that you're going to find at least few examples of how you can use it in your own project today. All right, thank you all for listening. And if you have any questions, don't hesitate to contact me using the contacts on the slide. Or if you just want to chat, then just approach me after the talk. I'd love to discuss more complex examples. And again, thank you for listening. It was a pleasure.